In this video, I'm going to go through problems, well, from 2 on in the review for the graphing exam, exam 4. So first of all, you had to plot 4 points. So let's go ahead and do that. 1, negative 2, you start at 0, 0, you go right 1 and down 2. And there's that one. Negative 4, negative 5, you go 4 to the left and down 5, and that gets you to that point. 0, 4, you go 0 in the x direction, so we don't move right or left, and then we go up 4. And then negative 5, 2, we go 5 in the negative x direction, and then up 2, since it's positive 2. Notice, or I would remind you of the quadrants. We have 1, 2, 3, and 4. In fact, just think in terms of a C. You go counterclockwise here. So the point that is in quadrant 2 is negative 5, 2. Alright, let's move on to number 3. So here we have to determine if these are solutions or not to this equation. So 2, negative 1 is a solution if I plug in the x and y values and the equation is true. So I'll plug in 2 for x and negative 1 for y. We're going to get 2 plus 3 equals negative 1, which is not true. That's false, which means no, it's not a solution. For 5, 2, if I replace x with 5 and y with 2, I'm going to get 5 minus 6 equals negative 1. And that is true, that does work, and so yes, that is a solution to that equation. Let's look at number 4. So here you have 3 lines that you have to find the slope for. The first step is finding a couple of points on each line. You want to make sure that there are points that cross exactly where the lines intersect. So 0, 1 and 4, negative 2 is on the first graph. So we want to do rise over run. And I usually like to work from left to right, so I'll start at the left point. To get to the other point, I'm going to have to go down, in fact go down 3. And so the rise is negative 3. We'll always go on the y direction first because it's rise over run. So our rise is negative 3, which means we went down 3. We'll go 4 to the right, so our run is 4. And so the slope of this line is negative 3/4. Notice as you go from left to right, this line does go down, so we would expect a negative slope. Let's look at the next one. So here, 0, negative 1, and 3, 1 are on the line. So again, I'm going to start on at the left, and I'll go up 2. So my rise is 2, and then I've got to go right 3. So the run is 3, and so the slope of this line is 2/3. And of course, from left to right it is going up, so we would expect a positive slope. Now when I look at number 4, I know because it's a horizontal line, it's nice and flat, it's going to have a slope of 0. I don't have to really do any work there. If I had a vertical line which went the other direction, remember that slope would be undefined. Let's move on. On number 5, you've got to find the slope given 2 points. So we'll need the slope formula. And let's go ahead and label our 2 points, x1, y1, and x2, y2. And so now it's just a matter of plugging the numbers in. So y2 minus y1, that would be 2 minus 5. And then x sub 2 minus x sub 1 would be 1 minus 13. We're going to get negative 3 over negative 12, which reduces to 1/4. Let's look at the next problem. Alright, so on this problem, let's again write down the formula. We'll label our points. Let's go ahead and subtract our y values in the numerator and our x values in the denominator. Notice in the numerator we have 5 minus negative 2, so you do need to write this as subtracting a negative. So we end up adding the 5 and 2, we get 7, and in the denominator we get negative 6. So this is a slope of negative 7, 6. Let's look at number 7. So again, write down the formula. We'll label the points and plug in our numbers. So we'll have 5 minus 2 in the numerator and negative 3 minus negative 3 in the denominator. So notice we're going to get 0 here in the denominator, and so this line, or the line that passes through these points, would have a slope that's undefined. Alright, let's move on. So in this problem we're graphing y equals negative 2/3 x plus 4 by plotting points. And so we want to pick some x values. Actually, because of this 3, we want to choose multiples of 3. Numbers like 0, 3, and 6, or negative 3. So let's go ahead and choose x to be 0. So when we plug in 0 for x, we're going to have 0 plus 4, which is 4. So 0, 4 is a point on this line. Let's try 3. So we've got negative 2/3 times 3 over 1. Our 3's cancel, and we get negative 2 plus 4, which is 2. So when I chose x to be 3, I got y equals 2. And last choice, I'm going to choose 6. Notice this will be, if you multiply across, negative 12 over 3, which is negative 4. And plus 4, you're going to get 0 there. So let's go ahead and put those points on a line, or on the graph. Notice everything lines up real nice, and there's your graph. Now, this is the first of 3 methods we learned for graphing a line. I would remind you that you could also use the slope and the y-intercept and verify that this is the correct graph. You know, start at 0, 4, go down 2, and write 3, and you would get the same graph. So even though you may have to use a certain method on the test, you could always check it using any of the methods. Let's move on to number 9. So here we have to find the x and y intercepts. To find intercepts, we're either letting x or y be 0. So let's make a little xy chart. Let's choose x to be 0. So when I do that, I'm going to have 0 plus 4y equals negative 20. So we're going to end up with 4y equals negative 20, which means y is negative 5. If we let y be 0, we'll get negative 5x plus 0 is negative 20. That's just going to be negative 5x equals negative 20, and we get 4. So these are the 2 special points. We call them intercepts. Now remember, an x-intercept has a y value of 0, and a y-intercept has an x value of 0. So I'll go ahead and plot those points and draw the line through them, and that's the graph. Let's go ahead and do 9b. So we'll do the same thing. We'll make an xy chart. Let's choose x to be 0. So we're going to have negative 8y equals 4. Divide by negative 8 to get y by itself. Now notice 4 over 8, that's 1/2, so this is going to equal negative 1/2. If we let y be 0, we have x minus 8 times 0 equals 4, which is x minus 0, which is just x, equals 4. So when we chose y to be 0, we got x equals 4. So let's put those points on a graph and draw the line, and we're done. Let's move on to number 10. So here you have to find the slope and y-intercept. So the best way to do this is to put this in slope-intercept form. So notice I've subtracted 3x on both sides. I'm dividing by negative 2. I'm going to get y equals 3/2 x minus 4. Now that's in slope-intercept form, which tells me my slope is 3/2, and my b here is negative 4, so my y-intercept is going to be 0, negative 4. Now if we have to graph this, we can put 0, negative 4 on our graph. we'll rise 3 because our rise is 3. We'll run 2, and so there's your line. Let's move on to 11a. So in both of these, we're just solving for y so that we can find the slope and y-intercept. So let's subtract 2x on both sides on this first one. And notice that's a negative 1y that we're left with there. We'll have to divide everything by negative 1. We get y equals 2x minus 3. So our slope is 2, and the y-intercept is 0, negative 3. Let's look at the other one. We're going to have to subtract 3x on both sides. We get 5y equals negative 3x minus 4. Let's divide everything by 5 to get that y by itself. And so we get y equals negative 3/5 x minus 4/5. So our slope is negative 3/5, and our y-intercept is going to be 0, negative 4/5. Let's move on to number 12. So y equals 1/2 x plus 3. We know our slope is negative 1/2, and our intercept is 0, 3. So on these graphs, or these equations, we're going to graph them. In this case, using the slope and the intercept is going to be the best way. Notice I'm going to write my slope as negative 1 over 2. I could have written it as 1 over negative 2. Either way will work, but you don't want to make the numerator and denominator both negative. That would be something that's positive. A negative divided by a negative is a positive. So here we're using negative 1 over 2. So we'll start at our y-intercept 0, 3. Make sure you put your y-intercept on the y-axis, which this one is. And we're going to go down 1, because our rise is negative 1, and right 2, and so there's your line. Let's move on to number 13. So this is one of our special cases. We do get a line. So if you put a point where x is equal to negative 3, you're just about done. We need to remember that this is going to be a vertical line going through x equals negative 3, so it's that line there. Now if it's helpful, you can make a table of values and just pick some x values of negative 3, since x will always be negative 3 for this equation, and you could choose anything for y. So notice those points are all on this line. So x equals a number is always going to be vertical. Again, I would remind you the slope of this line is undefined. Number 14. So the easiest way to do the graph for this one is to get this solved for y. We'll subtract 3x on both sides, and we're going to need to divide by negative 1 next. So we end up with y equals 3x minus 2. So our slope is, we're going to write it as 3 over 1, and our y-intercept is 0, negative 2. So we'll start at 0, negative 2. We're going to rise 3 and run 1. And so there's your line. Let's move on to number 15. So here, you want to be careful. This is not one of our special cases because x and y are both in this equation. Certainly the slope is 2/3. And if you think about it, the y-intercept would have to be 0, because if we let x equal 0, 2/3 times 0 is 0, so y would equal 0. The other way to think of it is you could put a plus 0 there, but either way you're going to get a y-intercept of 0, 0. So let's go ahead and plot 0, 0. Let's rise 2 and run 3, and let's draw the line, and we are done. Let's move on to number 16. Now in this one you actually have two ways you can do this. Since negative 2 and 4 are divisors of negative 8, it turns out that using the intercepts is a nice way to graph this. I'll do it both ways. So I'll make an xy table. If I choose x to be 0, notice here we're going to get 4y equals negative 8, which means y is negative 2. If I choose y to be 0, we'll get negative 2x plus 4 times y equals 8, with y being 0. So we get negative 2x equals negative 8, which means x is 4. So we'll use these 2 points to do the graph, or we could solve for y and use the slope and the y-intercept. So you could subtract 2x on both sides, divide by 4, you get y equals 1/2 x minus 2. I'm going to go ahead and use the slope and the intercept. So we'll start at 0, negative 2. We're going to rise 1 and run 2. And so there's your line. Now notice 0, negative 2 is on this graph, and also 4, 0. So we could have graphed this either way. It doesn't matter which technique you use. Let's move on to 17. Now this time notice 4 and 3 are not both divisors of 9. The 3 is, but not the 4. So I think I would just solve this one for y. So we'll subtract 4x on both sides. We'll divide by 3, and we get y equals negative 4/3 x plus 3. So our slope is negative 4/3. I'll write it as negative 4 over 3. And our intercept is 0, 3. So let's go ahead and plot 0, 3 on the graph. We're going to go down 4 because my rise is negative 4. And we're going to go right 3 because the run is 3. And there's your line. Let's move on to number 20. Notice I skipped a few numbers. Don't know why I did that. Anyway, so here we have to write an equation of a line. And so we learned that we're going to need the point-slope form of the line. And we're just going to plug in the numbers. So notice the point x1, y1 here would be 6, negative 4. We're going to substitute where the subscripts are. So that's my given point, and we'll use the slope there. So we have y minus the y value of my point, which is negative 4, is equal to the slope, which is 1/2, times x minus the x value of my point, which is 6. The left side we can change to y plus 4. And notice on the right side we'll distribute the 1/2, and then we need to do 1/2 times 6. Well, 1/2 of 6 is 3. You could also multiply it out like I did here, but it's going to be minus 3. So one more step, we need to get the y by itself. So we'll subtract 4 on both sides. You get y equals 1/2 x minus 7. Let's look at number 20. So here, if I'm going to draw or write an equation for a line, I'm going to need the point-slope form. The only problem is, to use the point-slope form, you need a point and the slope of the line, and we don't know the slope. So we can pick one of our points, but we're going to need to use both points to find the slope. So here's the slope formula. Let's label our points and find the slope. And you should get 1/3 when you do that. So now we're going to use 1/3 with the point 4, 3. It doesn't matter which one I use, but I like 4, 3 because they're both positive. So we're going to get y minus 3 is equal to 1/3 times x minus 4. So let's go ahead and distribute on the right side. 1/3 times 4 is 4/3. So we're going to get minus 4/3 there. And then we need to add 3 to both sides. So this one's a little bit more challenging than some of the other ones we did because we've got to combine negative 4/3 with 3. So when you do that, you need a common denominator. We can write 3 as 9/3, and when you add those together you get 5/3. So our answer is y equals 1/3 x plus 5/3. On this problem here, when we solve for x, let's just go ahead and do CSI. We don't have any fractions to clear, but we do have some simplifying to do. Let's distribute on the left. And notice we got that minus in front of parentheses. You're going to have to distribute a negative 1, so the x will become minus x, and the minus 3 will become plus 3. We also have like terms on the right, so we can add the 9 and 3 to get 12. And then we've simplified. At this point, we need to get x on one side only. That's what the I stands for. We want to isolate on one side, isolate x on one side only. So let's subtract x from both sides. Add x to both sides. We're going to get 8x minus 28 equals 12. We'll add 28 to both sides. And we're going to end up getting 5 here when we divide by 8. Let's move on to 23. So here we have fractions. So again, if we're doing the CSI thing, the first thing we need to do is clear fractions. So the LCD here is 12. So we want to multiply each term by 12. Basically, we're multiplying both sides by 12. So we're going to get 24x over 3 minus 48 equals 24 plus 12 x. Well, that's going to lead to 8x minus 48 equals 24 plus 3x. Again, we want to get x on one side only, so we've cleared fractions, we've simplified. Now we're getting x on one side only. And we got a two-step equation. We'll add 48 to both sides and then divide by 5. So final answer is 72/5. On number 24, we've got to find the value of this expression or evaluate it for a equals 2 and b equals -5. So I've made a skeleton or a shell. Let's plug in 2 for a and -5 for b. And now we need to follow the order of operations. So 2 squared, that's our highest priority, is the exponent. We're going to get 3 times 4. And now we have 2 multiplications to do. And we'll subtract last. Subtracting a negative, we add the opposite. So we're going to get 32 here. Let's move on to the last problem. Now here the highest priority is simplifying inside parentheses, and we've got parentheses within parentheses. We want to work inside out, so we'll subtract 5 minus 10 first, and then inside the parentheses we'll multiply next. And so we're going to get 3 times -8, which is -24. I want to remind you on 24 and 25 that both of these are problems that you can put into your calculator to check your work and hopefully catch any mistakes that you might make. And that's the end of this review.